Hello students, welcome to practically one shot session for grade 10th. Waiting for more students to join. Share this with your friends so that they can also join in time. Those who are present here, share this link with your friends so that they can also join. Soon we will begin this session, okay? Just waiting for 1 or 2 minutes more so that more and more students are here and we interact more and we learn more together, okay? Do share this link with your friends. Okay, so let's begin. Hello, I welcome you all to the one shot session for grade 10th. A very good afternoon or good evening, whatever you say at 5:30. So a very good evening to all of you. So today we will be discussing the topic triangles. Okay, before that, let me tell you about what practically exactly is. Practically, as you know, is an e-learning platform where you can learn all the subjects related to sciences or mathematics from grade 6th till grade 12th. Even you can learn coding from our application. Okay, you will be getting 3D models or AR/VR simulation videos at our application. So do download our application and like see all these videos. You will enhance your learning definitely. For that, you just need to download practically application from your Play Store and you can see all the courses we have over here at our platform in view all courses, which is nearby this practically live, and you can see list of courses. You can even see after clicking the syllabus we are covering in that particular sessions. Okay, and after that get enrolled with us. There are some even free sessions we are providing at our YouTube channel, so you can also see how we are interacting with students and do like enroll with us for our paid session so that you can clarify all your doubts and learn more with our application and with the teachers and their personal like sessions over here. Yeah, Gagan, hello. So you are ready for this triangles one shot session? Firstly, let me know how many of you have covered this chapter. This is the third chapter we are covering in one shot session. So before starting this, just let me know how many of you have covered this triangles chapter already. Let me know in the chat section how many of you have covered this chapter already. Those who haven't done can write haven't done, they haven't done this session, this topic. Okay, none of you is replying, so I'll continue with this chapter. Okay, so let's just begin. In this chapter, we will be covering four major topics. Those four major topics are: firstly, we will be understanding what similar triangles are, and we will discuss its properties. Right? What properties are satisfied by triangles so that they can be called as similar triangles. Okay. Next, we will be discussing basic proportionality of theorem and its converse. This is also the most important topic. This theorem is the most important, which has to be covered so that like most of the questions of similar triangles can be solved, right? Next, we will be discussing the criteria. What criteria makes the two triangles similar? So criteria for similarity of triangles. Next, we will be discussing area of two similar triangles, how areas of two similar triangles are related to each other. Okay, so let's just begin with the session with first topic. First topic here is similar triangles and their properties, right? So we have Firstly, we will be discussing what are similar figures, right? After that, pinpointing towards the triangles only, okay? So similar figures are those figures which are in same shape but are in different sizes. For example, we have considered here two line segment. You can see here, these are the two line segments, right? One is shorter as compared to other. So they are having different sizes, but they are having same shape, right? So we will call these two line segment as similar. Hello Manoj, hello, welcome to the session. So we are discussing here about similar figures. So here we have any two figures which have same shape but different sizes are known as similar. So first example is of line segments. Next we can have an example as any two circles are similar. Any two circles are similar, right? Whether they are of same radius or of different radius, it will only differ their sizes, but they will definitely of the same shape. All the circles have same shape, right? A round shape. So they are always and always similar. Yeah, Manoj, yesterday I didn't took the class. It was for some other, I was allotted some other class. So no issues for this month, like this week you had a different schedule, right? So do follow this schedule. So even your quiz session will be on some other day, like it will be most probably on Friday. So be prepared for that quiz round also, okay? Okay, you were waiting for the session yesterday. No issues, I have this session with you today, okay? So let's learn today only, okay? So any two circles are also similar, right? Or any other figure you can say, any other example from your side which you can give as similar. Can you give any example of similar figures? Squares, yes, squares are also similar. Any other, like Manoj, you can also answer example of similar figures. Yes, squares are also an correct example for similar figures, right? Next, I have here as an example of equilateral triangles are always similar, right? More example is as said by here, but Gagan said like squares are similar. Here is an example of squares also. Squares, equilateral triangles, circles, line segments, these are always similar. Okay, so I think now you are clear with the idea. When do we say that the figures are similar and when do we say they are not similar? Like you can't say that a line segment is similar to a circle, right? Those which are similar figures must have same shape. So they must have same shape, but they can have different sizes. Only then we can have two figures as similar. Even if their sizes are same, even then we can say that they are similar. But there is an enhanced way to say that they are even congruent if they have same size, right? You have read this earlier in your grade 9th, right? So now coming towards the similar triangles, right? So from similar triangles, for triangle is basically a polygon. So we will be discussing what are basically the similar polygons. Any two polygons are said to be similar if their corresponding angles are equal as well as length of their corresponding sides are proportional. Any two polygons, take any two polygons, whether having 3, 2, 3, 4, 5, 6, any number of sides. So all those polygons which have corresponding angles as equal and their length of the corresponding sides are proportional are known as similar polygons. For an example, here I have taken a quadrilateral, right? Here angle A, this angle is equals to angle E. Angle B is equals to angle F. Angle C is taken to be equals to angle G and angle D is taken to be equals to angle H, right? So it means that its corresponding angles are equals, right? So we have corresponding angles equal. Even we have the sides in proportion. All the sides are proportional. I have written it over here as an equation. AB by EF is equals to this AB by EF is equals to BC by FG is equals to CD by GH is equals to DA by HE. These are the properties which are satisfied by similar polygons. Okay. For an example, you can always consider, like here I have taken example with magnitudes over here. Here these angles are always, these corresponding angles are equal, and even you can see that proportionality of sides I have given over here. All these ratios I have calculated, and after calculating each ratio, the corresponding side ratio of both the polygons, they are all equal to 3 by 2. If they are all equal to 3 by 2, that means all of them are equal to each other. So if all of them are equal to each other, that means their corresponding sides are proportional. If their corresponding sides are proportional, that means they are similar. If either of the result is satisfied by any of the two polygons, then they are definitely similar. Okay. Yeah, sides are in the same ratio. If you have been given with angles, then you can compare with angles. Okay, but here you were given with sides, length of sides, right? So that's why you have compared the ratio of the sides. Okay, got my point? Everyone got my point? How we have compared the sides? This 6 by 4, 12 by 8, 15 by 10, 9 by 6. We have compared all these. Right. Now coming towards the similar triangles, which we want to deal mainly with. Okay, so we have similar triangles. So as in the case of polygons, we were having like either the corresponding angles are equal or corresponding sides must be proportional, then we say that two polygons are similar. Same case holds over here, because triangles is a kind of a polygon with 3 sides, right? So same case holds over here. If either the corresponding angles are equal or the corresponding sides are proportional, then we say that triangles are similar. Or if we say that triangles are similar, then both of these hold true. This is both way condition, right? So yeah, Manoj, polygon is a closed figure with any number of sides you can have. Like this triangle is a closed figure which is having 3 sides. Quadrilateral is a closed figure which is having 4 sides. Similar way you have pentagon, hexagon, right? All these are polygon, which are basically the closed figure. Okay, got the point? Next, how we can like write it in the mathematical form, how we can basically write the statement in mathematical form. Here angle A, this angle is equals to angle D, angle B is equals to angle E, angle C is equals to angle F, right? All these are equal to each other. That means corresponding angles are equals to each other if these two triangles are said to be similar, right? Even their sides are proportional to each other. AB is divided by DE is equals to BC divided by EF is equals to AC divided by DF, right? So we have these two conditions true whenever we are given with two similar polygons, or here we have in particular two similar triangles. We will mainly deal with two similar triangles because your chapter is only based on similar triangles. Okay. Yeah, Gagan said if two angles are equal, then automatically the third angle will be equal. Yeah, definitely. If two angles of two triangles are equal, corresponding angles are equal, definitely the third angle would be equal. We will discuss this in detail when we will reach to the criteria for saying that the two triangles are similar. Okay, we will discuss the criteria in third topic today itself. Okay, after covering a theorem based on this. Okay. Next, we have a basic proportionality theorem. This is also known as Thales Theorem. In some schools, they say this as Thales Theorem, or they say this as Basic Proportionality Theorem, or they even write this in short form as BPT. Okay, all these may mean the same thing. Either they have written BPT, or they say Basic Proportionality Theorem, or they say it as Thales Theorem. Okay, all mean the same. So what exactly does the statement says to us is, if a line is drawn parallel to one side of a triangle, like here I have drawn a line PQ which is drawn parallel to BC, but how I have drawn it parallel, intersecting the other two sides, which intersects the other two sides. That's why I have drawn it this way. Otherwise I would have drawn it over here, right? So the line which is drawn parallel must be intersecting the other two sides of the triangle. So I have drawn it this way. Then what does this theorem states? Then it divides the two sides in the same ratio. Two sides, these two sides AB and AC, these are the two sides where the line is intersecting, right? So what this line does is, if we draw PQ which is parallel to BC, then this P and Q points divide AB and AC in the same ratio. What does this exactly mean? This, if we have a triangle ABC, we have here triangle ABC, right? Here PQ is parallel to BC, this is drawn, right? And intersection points are P and Q respectively. We have here intersection point as P, we have here as Q. Then what does this theorem says? Then according to this statement we have this result. And what is this result? This length AP divided by length PQ is always equals to AQ divided by QC. That means here we have written, then it divides the two sides in the same ratio. Same ratio basically means when you like write AP by PB, which is the ratio we have for AB side, and for AC we have AQ by QC. We have these ratio as same. So that's why we have this result of basic proportionality theorem. All of you got the result, how we have derived this result or how we have written this. We will do the derivation after this. Are you all clear with the statement? Okay, you are clear. Let's just do the proof of it quickly. Okay, so for proving this, what you need to do a construction. What exactly is the construction is, I have joined B point with Q and I have joined point P to point C, right? They are just, these points are just joined to each other. What is the next construction over here? I have drawn a perpendicular on AC through P, that is PM is drawn perpendicular to AC and QN is drawn perpendicular to AB, right? So here we have our construction. BQ is joined, P and C are joined, and we have a perpendicular on AB from Q and a perpendicular on AC from point P. Everyone got the construction? Okay, so we will discuss now the proof, how exactly the proof will go for this. So its proof involves, like, we will find the area of triangle APQ, right? We will write the area of APQ. Now there are two ways of writing the area of APQ because there are two perpendiculars, right? We can once consider the base as AP and once we can consider the base as AQ. We will write the area from both the ways, right? Firstly, we have considered here as area of APQ, area of triangle APQ, that can be written as half into base into height. Now for this time I have considered AP as its base, so its base value is AP. Now height for this would be QN, so QN is height, half into base into height. This formula I have used, right? Now similarly with using this same formula, you can find area of triangle PBQ, PBQ, this triangle. Area of this triangle you need to find. Now for this triangle we need, basically we have this as our base, right? We have PB as our base value, but what would be its height? Its height would be same, QN, right? For obtuse angle you mainly know that its height lies outside the triangle, right? So you have QN as its height, so half into PB into QN is the area of triangle PBQ. right? Now similar way we will write the area of other two triangles, like one would be this triangle and one again for APQ, but with other another base value. We will now consider this as the base value. So that can be written as like this: area of triangle APQ can also be rewritten as taking AQ as the base. Once I have taken AP as the base, now I have taken AQ as the base, right? So similar way its height would change. Okay, so height is mainly changed for both. And similar way as we have done for PQB, area of PQB, in the similar pattern I have written the area of PQC. For PQC, you have half into base would be considered as this QC and its height will be PM, right? So you have half into base, that is QC, into height, that is PM, as its area, right? So we have written the area of 4 triangles. Basically these are 3 triangles, but for one triangle I have written the area in 2 forms. So we have basically the 4 areas. So now what next we would do, we would find the ratio of these areas. How? Firstly, we will find the ratio of areas of triangle APQ and PQB, ratio of these two basically. If we divide area of triangle APQ by area of triangle PQB, then we have half into AP into QN. We have written over here half into AP into QN divided by half into PB, same over here, into QN, right? Now what next we have over here is that QN will directly be cancelled and half will directly be cancelled. You will left only with AP by PB, right? So you are left only with AP by PB. So this is the first equation we have, and for the next equation we want the other area. Like here we have divide these two, then we will have area of triangle APQ divided by area of triangle QCP. That will be half into AQ into PM over half into QC into PM. Similar pattern, PM will be cancelled, half will be cancelled, you will be left with AQ by QC only, right? We are doing it like this only because we basically want like some ratio of these sides. So if we want the ratio of this side by some way which you know previously, you must find the ratio, and for that ratio we have considered this area. Now you can see that whatever result we were having in BPT have these ratios in it, right? The ones I am marking right now have the actual result of BPT have these result in it. So we have recreated the result using the by using these areas formula, right? We have used the formulas related by relating this areas, and we have recreated this ratio. Now if we want to say that RHS are equal, we basically need to prove that RHS of first equation and RHS of second equation are equal, right? Now you can see numerator of LHS are same, right? We just need to prove that denominator are also same, and then we will be done with the result. You are getting how we are proceeding and how this was an easier way to proceed with, because most of the terms are cancelling over here and we are getting the required or desired ratio to prove the BPT result. Okay, so what next? We basically want to see that the LHS, the denominator in the LHS must be proved equal. So that this LHS is equal, then definitely RHS would be equal to each other. So we have numerator of LHS as equal. We need to prove for denominator. So for denominator, yeah, you are right. For denominator, we have these two areas. These two areas are between some parallel lines and they have same base. So triangles which are in between the same parallel lines and having the same base have same area, Right, you are right, Manoj, over here. So, according to the property of triangles, the triangles drawn between the same parallel lines are on the same base have equal areas. So, using that property, area of triangle PBQ is equals to area of triangle QCP, right? Area of this triangle would definitely be equals to area of this triangle. So that means the denominator of these LHS are equal. If denominator of LHS is equal, that means LHS of both the quantities are equal. That means RHS would be equal. If RHS are equal, that means you got the result for your BPT, basic proportionality theorem. All of you got the proof. Everyone got the proof? How we are proving this? Yeah, you got it. That's great. So there is one more like a result which is a kind of important result which is related to basic proportionality theorem. We would discuss it. So here is the basically the proof of it. So for that you have an important result which is related to basic proportionality theorem is that from basic proportionality theorem you have this equality with you, right? So what next I'll do is yeah, you can see that here you have AP by PB, right? Yeah, converse of BPT we will do after this result, okay? So here you have AP by PB over AQ by QC, right? So here you have this much equality with you, and what next you can do to derive an important result is taking the reciprocal. I have taken the reciprocal of this equality. What next I'll do is I'll add 1 to both the sides. If I add 1 to both the sides, then what would I do next? I'll take the LCM on both the sides. If I take LCM on both the sides, it would be PB plus AP over AP is equals to QC plus AQ by AQ. Okay, why should we add 1? Like I am not proving something like this, like I can explain it the way like I have added 1 to generate some result which is somewhat a bit different from this basic proportionality theorem, nothing else. To derive some another result you have to do something like some operations on the given equality, right? So that basic operations I am doing. From the result you will definitely see that why we have done with this procedure. Okay, this procedure I have done basically to let you know when you get some questions in your examination, there you get some proof like assertion and reasoning, right? In assertion and reasoning mostly the questions would be something like related to the pointers which we are using in proofs, right? So that's why I am giving you proofs of most of the questions or most of the results, so that you can easily deal with all those assertion and reasoning. Okay, by adding 1, basically what we have done, if we add 1, so if we take the LCM, right, you will see that PB plus AP. From the figure you can see that PB, this quantity, plus AP means something in geometry, right? It can be written as AP. This quantity can be written as AB. So that's why after adding 1 to this, I'm recreating some like another formula to this, right? Similar on the RHS, in the denominator you can write this as AC. QC plus AQ is all equals to AC. So you will have the result as AB by AP is equals to AC by AQ, right? So that would be equals to, if I again take the reciprocal, you will be having AP by AB is equals to AQ by AC. Now you can see from the result what we have as AP, this quantity divided by this complete length, is equals to this much length divided by this complete length, right? You are getting this result. Now you can even see this as another result for your BPT, right? This is another result which is actually considered quite similar to your basic proportionality theorem. Okay, so you can even use this result directly in most of your questions. And even like you can say that PB, you have the result as AP by PB, AP by AB is equals to AQ by AC, right? You can even write this result as PB divided by AB, like this much length divided by complete length is always equals to QC, this much length divided by complete length, that is AC. You can even write the result as this. These two results can be even directly used, and for proving this I have basically done this procedure, like taking reciprocal then adding 1 to this. Okay, all of you got the result, how we have derived this and what exactly is the result. You can use these results directly. You need not to prove this even if you get some proof based question. In this session you are not getting proof based questions, that's correct, but in reasons what should we mention, you can even write BPT, because this is some direct result which is related to BPT. You can even write this as BPT, but actually the BPT says this, but this result can be also written under BPT. Okay, this is a kind of a sub result or a remark which is based on BPT. Okay, so next we have converse of basic proportionality theorem. For the converse of basic proportionality theorem, let's just discuss the statement. Here the statement says that is stated as, if a line divides any two sides of a triangle in the same ratio, like I have drawn a line PQ which divides AB and like AB and AC in the same ratio. That means if we have this equality with us, that means AP by PB same ratio is AP by PB is always equals to AQ by QC, then we have this line parallel to BC. This is what the converse says to us. If we have ratio as equal, this time we have ratio as equal, then the two lines are parallel to each other. Okay, I'll just discuss fastly over here the proof of this. For proof of this, you just need to construct here a line. Suppose that this line is not parallel to this. Suppose these are not parallel. Okay, so if these are not parallel, there must be some line passing through P which is parallel to BC. So then suppose that PQ dash is parallel to BC. I have constructed a line PQ dash which is parallel to BC, right? So what would the proof next includes? Now if PQ dash is parallel to BC, that means AP by PB is equals to AQ dash by Q dash C. Using BPT, by the result of BPT, we have AP by PB is equals to AQ dash by Q dash C. Now from this result which we have, like this is a given statement to us. Comparing the LHS on both the sides, we have RHS to be equal, that is we are having this statement. Now if we have this statement, compare both the sides, you will get that Q point is same as Q dash point. Now if Q and Q dash are same point, that means this PQ is parallel to BC, as our construction says this. Okay, so you can even like recall the formula or like proof from this. This is a 2-3 step result or proof, you can say. Okay, next here is the question for you to solve. This is mainly based on basic proportionality theorem, so try solving this question. This is an MCQ based question, so most of you would be getting like this questions in your September examination also. So try this question. You are having time for 1 minute. The result which we have just learned about the basic proportionality theorem, try solving with that and let me know what will be the answer, A, B, C or D. Everyone try, you are trying, right? In this figure, you have DE parallel to BC. These two lines are parallel. This is given to you. Now, if AD over DB is equals to 4 by 13, that means ratio in which D points divides the length AB is given to you. You need to find the value of AE. Manoj said B as the answer. Okay, we'll see that whether you are correct or not. Others answer quickly so that we can proceed. Answer it quickly. Okay, I'll solve with you over here. Here we have AD by DB is equals to 4 by 13. Now, we are given with DE parallel to BC. As DE is parallel to BC, so what we will apply? Basic proportionality theorem, or we will apply its converse? What we will apply over here? Basic proportionality, or we will apply converse? What are we going to apply? Okay, yeah, we are going to apply basic proportionality theorem over here. So it satisfies the condition of basic proportionality theorem because it divides the two sides of the triangle, and it is DE is parallel to third side. That means we have AD by DB is equals to AE by EC, and this is given, AD by DB is given to be equals to 4 by 13. Right, now AE by EC, you only have this complete length with you. AC is given as 20.4 centimeter. You don't have this AE or EC, right? You don't have these lengths. So what you can do, again, what you will do, you want to form an equation which involves only AE and AC. So that will that might be recalled by the formula which we have derived from after the BPT result and before the converse. So that procedure must be recalled in your mind, right? So what you will do next, you will take the reciprocal of this. Yeah, Gugan also said B part. Yeah, I hope that B part is correct. Let's just solve this. EC by AE is equals to 13 by 4. Now add 1 on both the sides. You will have EC plus AE divided by AE is equals to 13 plus 4 by 13, right? So it will be 17 by 13. You have AC by AE is equals to 13 by 17 by 13, right? So just try here. I'll have 4. I have written it wrongly. It is 4, right? So AC by AE is 17 by 4. Just put the value of AC over here as 20.4 and solve for AE. You are saying B part as the answer. Let's just see. It has answer as B part. So you are correct. B part is the correct answer. Clap for you. You have done it quickly and you have answered it accurately. So let's just do the next question. Here you have the next question as triangle, like here we are dealing with quadrilateral, not as a triangle this time. ABCD is a quadrilateral. P, Q, R and S are the points of trisection of sides AB, BC, CD and DA. What does trisection means? You might know about something about bisection. One word is bisection and one word is trisection, which is most commonly used. What is meant by trisection? Anyone? Anyone from the chat section who can answer? Bisection basically means if you have this line segment, right? If you have this line segment, yeah, I'll teach you how we will draw this figure. Okay, so I'm just explaining this word. What does this trisection means? Yeah, it makes in 3 parts. For bisection you have a point which divides the line segment in two parts, but in trisection you will divide it in three equal parts. That's the important thing. It will definitely divide in three parts, but those three parts will be equal. Okay. So next, here we have P, Q, R, S are the points of trisection of sides AB, BC, CD and DA respectively and are adjacent to A and C. Check whether P, Q, R, S is a parallelogram or not. Okay, so now let's just discuss its figure. For figure, you need to draw a quadrilateral. Okay, let's just draw a quadrilateral. I have drawn it for here for you. I have drawn a quadrilateral A, B, C, D. That's it. Okay, so here we have given that those pointers which we want to plot are close to A and C. That means they are adjacent to A and C, right? So I have drawn a line A and C so that I know I need to plot the points closer to A as well as C. Okay, so here see, P point is the trisection point for AB, right? Here we have AB. Let's just trisect this. I have marked here 2 points which trisect all these. Now we need to know whether this point is P or whether this point is P, either 1 or 2. Which point will be P? For that we would again read this line. The point which we need to take is adjacent to A. That means this point will be P, not this point. Getting my point? Why we have considered this point as P and not this point? Anyone having any doubt why we have considered this point as P and not the other point? Okay, yeah, you got the point. Okay, so in similar way, when we need to plot the point Q, you need to plot it on the trisection point of BC, but it must be either close to A or close to C. Okay, so here we have B and C length, so trisect it. Now it would be closer to C if we take this as Q, right? Now trisect this again. For CD you have trisection point as R. Now if you trisect this, you need to be closer, adjacent to C, so this point will be R. Again, if you trisect this point closer to A, that will be S. Got how we have plotted these points P, Q, R and S. Now you need to check whether P, Q, R, S is a parallelogram or not. For that, just draw this parallelogram or whatever it is, just draw this quadrilateral. We basically need to check whether this is a parallelogram or not. So I won't say that this is a parallelogram, but this is a quadrilateral definitely, right? So I'll draw this quadrilateral. So we have this quadrilateral with us. Okay, I'll remove all other points which just creating the mess. Okay, so now you have this quadrilateral with you. So if you have this quadrilateral with you, if this is a parallelogram, then these PQ must be parallel to SR and QR must be parallel to PS. We want to use converse of this. Yeah, we will use converse of this. How we will basically use this? Here AP and this AP length was equals to this much. If I say this point as suppose O, right? So AP is equals to PO is equals to OB, right? Because P is the point of trisection, P and O are the points of trisection. That means if this length is X, this length would be X and this length would be X. That basically means a P point divides AB in the ratio 1:2, right? How 1:2? AP basically, now you have this length AP is to PB ratio in 1:2. You are getting how we got 1:2 ratio? And similar way we will get this BQ is to QCS 2:1 ratio. Again here we will have 2:1 ratio. Again here we will have this 1:2 ratio. right? So you have these ratios somewhat similar to each other. You just need to take these. Suppose you are in triangle. Suppose you are in triangle BAC. You are in triangle BAC. Okay. So in this triangle, BP divided by PA is equals to 2:1. Right, and this is same 2:1 ratio is also for BQ by QC. Right, so that implies by applying the converse of basic proportionality theorem, you will have PQ is parallel to AC. Right, so using this result, you will apply converse of basic proportionality theorem, and after applying the basic converse of basic proportionality theorem, you will have this side parallel to this AC, right? Similar way, while applying it for triangle DAC, you will have that SR is parallel to AC. Right, so you will have SR as parallel to AC and PQ is parallel to AC. If two lines are parallel to the same line, then they are parallel to each other, right? So PQ would be parallel to SR. PQ will be parallel to SR. This is the first result we have got. Everyone got the proof for this first equation, like first result. PQ is parallel to SR. Yeah, Manoj is saying PQRS is a parallelogram. Yeah, it would be a parallelogram. How can I say that? Now, PQ is parallel to SR. The similar way how we have proved that PQ is parallel to SR, draw a line joining BD. Basically, draw the other diagonal. Use the same results and prove that this PS is parallel to QR. Similarly, you can prove that PS is parallel to QR, right? So now these PQ is parallel to SR and PS is parallel to QR. That means opposite sides of quadrilateral are parallel. Yeah, it has one parallel, but if one is parallel, you can't say that it is parallelogram. It can be even trapezium, right? So it need not to be parallelogram always. For this to be this quadrilateral to be a parallelogram, it must have both the opposite pairs of sides as equal, right? So for that, you need to prove both the results. The lines I have been making. Yeah, Sherry, you said something that you understood the topic. That's great. You need not to say thanks. Okay, just share this link with your friends so that they can also join with us and get benefited from this lecture. Okay, so I hope you all got the result. Like, we need to prove both the lines to be parallel to each other. Okay, so if both the opposite pairs of lines are parallel to each other, that implies that the quadrilateral we have is a parallelogram. Okay, let's just switch to the next topic. Next topic we have here is criteria to decide whether two given triangles are similar or not. Okay, you will definitely do that. That's great. Are parallel, then they are parallelogram. If two pairs of lines, like suppose you have some quadrilateral, whatever quadrilateral you have, if opposite pairs, like opposite lines are parallel to each other, only then you can say that it is a parallelogram. And if you want to prove it some other way, then you can prove it like this. Prove this line is parallel to this line, and even prove that this line is equals to this line. Only then you can say that this is parallelogram. But if you have these two lines parallel only and these two lines are not proved parallel, then you can't say that this is a parallelogram. We can even construct a trapezium like this, in which opposite sides are, one of the pair is parallel but other is non-parallel. So this is not a parallelogram, right? So for this to be parallel, you need to prove either both the both the pairs of opposite sides as parallel. So I need to, okay, repeat what exactly you basically need to prove. For proving a quadrilateral to be parallel, what you will do, either prove both the opposite sides as parallel, okay, like we will prove this side is parallel to this side and this side is parallel to this side. You need to prove both the results. Or other way out to prove this would be, you prove this is parallel to this and again prove that the lines you have proved as parallel must also be equal. Even then this is a parallelogram. Okay, and if you have just proved that these two are parallel and you haven't proved either this is equals to this or this one is parallel to this, then you can't say this is a trapezium. You can't say this is a parallelogram. This could be a trapezium also. Okay, so let's just begin with the next topic. Okay, Yashwant, you said thank you. You need not to say thank you. Okay, I'm here to teach you. Just interact and more with me and ask your doubts, whatever doubts you have. Okay, so we will discuss criterion to decide whether two triangles are similar or not. First first criterion is, if you have two triangles as similar, you need to prove, basically here from this criterion you will basically prove whether the triangles are similar or not. For that, consider two triangles, right? This is known as, basically what I am teaching you in this slide will be known as triple A criterion, A criterion. In some books it is also written as A criterion. Why A criterion or triple A criterion? You would get this in this slide. Okay, suppose you have two triangles, okay, in which angle, here triangles are A, B and C, and next triangle is X, Y and Z. If you have a result saying that angle A, this angle A is equals to angle X, and a result which says that angle B is equals to angle Y, this angle is equals to this angle, right? And angle C is equals to angle Z, angle C is equals to angle Z, then we can say that both the triangles are similar. If you have this result with U, then you can say that these two triangles are similar. And why it is known as A criterion? Because this is a result relating angle, this is also a result which relates angle, this is also a result dealing with angle. You are saying that it's breaking. Okay, just wait a minute or two. Maybe either there is some issue from your networks, okay, because from my side it is all okay. Just wait for a minute or two, you will get to know where issue is from which end. Okay, in this itself, ma'am, two angles on. Yeah, exactly, you have repeated it again. I was about to say this to you, that if either of the two angles are equal, that means either you have this thing or you have this thing with you, then definitely the third angle would be equal. How? Anyone who can say how the third angle would be equal? Which property you will use? My voice is not clear for Yashwant. Yeah, Yashwant, it might be an issue from your side because others are saying that I am perfectly audible. Okay. Shruti, you are saying that using CPCT. No, CPCT is something you use in congruency. Here, for proving that the third angle is also equal, for that you will use the angle sum property of triangle. If you use the angle sum property of triangle, using the angle sum property of triangle, you will say that suppose I have this and this equal. Now to prove angle C is equals to angle Z, what I'll do, I'll write angle C equals to 180 degree minus angle A minus angle B, right? Here angle Z would be equals to 180 degree minus angle X minus angle Y, right? So here X is equals to A, right, and B is equals to Y. So that implies this quantity is equals to this quantity, that implies C is equals to Z, right? By angle opposite to equal sides are equal. No, Manoj, you are incorrect. I hope you all got the correct answer. We will use the angle sum property to prove this. So Sherry is saying I was audible to her at 5:55. Yeah, okay, complete, got it. There might be an issue from Yashwant's side. Okay, so you all got how we will be using this triple A criterion, or you can even say it as double A criterion, A criterion or triple A criterion. And some in different books you will find this differently. Okay. Next result to prove the triangles are similar is SSS criterion. This is SSS criterion. Earlier you were having as A criterion. Here why SSS? In earlier one you were having a property relating the three angles. Here you have a property which deals with the side, side and side. S basically means side. S stands for side, right? So what property you need to have so that the triangles are similar? You need to have this property. What does this property says? The sides of one triangle must be proportional to the sides of the other triangle. In exams, will they prove? No, you need not to prove these like criterion for similarities. Even this time you are getting like only MCQs or assertion reasoning type or case-based study questions. So you need not to do all these proofs. Even in exams which were subjective, very less number of times the proofs for this criterion was asked. Only the proofs related to BPTs or its converse was mainly asked. Okay, Yashwant, you said it was problem for your side. Okay, that's great. I think you can resolve it by now. Okay. So what does this criterion says? If we have sides of two triangles which are proportional to each other, then we have the two triangles as similar. What do we need basically? We need this result, then we can say that these two triangles are similar. What is this result saying? XY, which is this side, divided by PQ is equals to YZ, this side, divided by QR, this side, and XZ is divided by PR. If all these three ratios are equal, then we say that two triangles are similar. And while saying the two triangles are equal, we need to write in like ordered form. Suppose we write triangle XYZ, right? Even in the previous one, I'll write firstly in triangle ABC. We had here triangle ABC. For similarity, you use this symbol. Like in congruence, you use this symbol, right? This one was for congruence. In similarity, you just put this tilde sign, okay? So, ABC triangle would be similar to, instead of A, you will write here X, because A is equals to X, right? Now, B would be replaced with Y over here. C would be replaced with Z. So these two triangles are similar. Okay. So next here, triangle XYZ. This is similar to, so Ishwant, you are asking timings for what? Okay, here you have triangle XYZ. So XYZ is similar to PQR. Triangle PQR. You can't write this as RQP or QPR. You can't use this. Just write this in an ordered way. This proves that XY, like here you have XY divided by PQ, right? XY, first two terms here, first two terms here. Next, YZ divided by QR, YZ divided by QR, last two terms here, last two terms here. XZ, XZ, first and third term, here too, first and third term. So write this in ordered pair, okay? So if we have three sides proportional to each other, then even you can say that the triangles are similar. Okay, ma'am, live when, okay, I'm live on like at 5:30. This week I am live on Wednesday, otherwise mostly I am live on Tuesday. So you can see this on our website. It is almost like session is created earlier, 1 or 2 hours before actually session is happening. But mostly you will have the sessions on Tuesday and Saturday, that is from 5:30 till 7. Okay. 5:30, and most probably it would be up till 7, or it might be a little longer. Okay, so at 5:30 I am live mostly, so do join with all your friends. Okay, so this is the second criterion. Third criterion is SAS criterion. Okay, now you are familiar with the terms. S basically means side, here A means angle, and S again means side, and A is always written in between S. That means side, then you will have an angle in between two sides. Like you have two sides, a relation between two sides, and an angle which is in between them, you have the criterion based on it. What is exactly the criteria? If you have one angle which is equal in both the triangles, and you even have this ratio AB, this side divided by DE. Yeah, most probably from next week I will be live for 4 days, so that I'll cover most of your chapters by September. Okay. Yeah, you are right, Gagan. If a triangle has two sides in same ratio and similar, right? You are writing it correctly. So I'll discuss here. Angle A is equals to angle D. If angle A is equals to angle D, and the ratio which we have is AB divided by DE is equals to AC divided by DF. If we have both these results with us, even then we can say that the two triangles are similar to each other. And why we are saying this as SAS property? Because here side, here we have angle, here we have side. So this involves side angle side property. You can't just say that if B is equals to E and you have this ratio equal, then you can't use this result. You need to have an angle included in between these sides, though these two angles must be equal. Okay, so next, here is the question for you to check whether which one of the option or more it is and are true. So it might have one option as true, maybe two, maybe three or four. In this given figure, OA divided by OC is equals to OD divided by OB. Which of the following statements is or are true? Anyone from chat section who would like to answer? Try it quickly and let me know what will be the answer. You have just learnt all the criterions by now. First criterion was angle, angle, angle. Next was side, side, side. Next was side, angle, side. Right? So you have these three criterions. Use whatever is possible over here for you and check whether the triangles AOD and COD have something similar. Anyone who can answer? You're saying B part is correct. Okay, others answer quickly, waiting for you to answer. Quickly answer. Here it is written that which of the following is or are true. So you need to check all the options. It might have only one correct, it might have two correct or three or four correct. Do check all the options. Would know how to make. Okay, so you can just answer over here only by typing which one is the correct, Sherry. You need not to create and like show me all the time like how they are equal or whatever you are saying. You can just let me know by the options which one is correct. Okay, I'll do it with you. OA by OC, if we consider triangle, this triangle and this triangle, we have OA by OC is equals to OD by OB, right? This is given to us. Again, Gagan, you are saying B part. Okay, let's just take OA by OD is equals to OC by OB. Which criterion you are using? Those who have answered, which criterion you are using to answer the question? Which criterion? Which criterion out of these you are using to answer? You are using AAA. How you are using AAA? I haven't said any of these sides are parallel. I have just given you this ratio. So AAA is definitely wrong. Okay, let's just discuss. We have OA by OC is equals to OD by OB. And even in this triangle, this angle is equals to this angle. How we can say that angle AOD is equals to angle COD? Anyone who would like to answer why angle 1 is equals to angle 2? Anyone from the chat section who can answer why angle 1 is equals to angle 2? Yeah, these are vertically opposite angles. So vertically opposite angles would be equal, right? So we have a ratio of these sides and we have the angles in between them are equal. That means SAS property might be used, right? So you can just check OA divided by OC is equals to OD divided by OB. So how will you write the triangle is the most important thing. You will write, suppose you have written AOD, right? So this is similar to triangle. For O, you have O over here. You need to just find whether you will write COB or you will write BOC, right? No, they are not of same length. They are in same proportion. Sherry, you are wrong here. They are not of same length. They are in same proportion. AOD, here AO is related with OC. So that means instead of A you will write C and instead of D you will write B. So AOD is similar to COD, right? If AOD is similar to COD, that implies first angle would be equals to this first angle, like D would be equals to B. So and this AOD is equals to COB, which we have already proved using vertically opposite angles. So by SAS we have proved that these two triangles are similar. Now from this we have angle A is equals to angle C, right? And angle D is equals to angle B. So we have this also as a result. So we have two result as option A and option C. Anyone having any doubt how we are having this result? Okay, I need to repeat it once again. Okay, I'll repeat. We have angle 1 is equals to angle 2. We have angle 1 is equals to angle 2 by vertically opposite angles, right? But by using vertically opposite angles, angle 1 is equals to angle 2. We have these two angles equal and the sides by which this angle is formed are in proportion. Here it is given that they are in proportion. OA by OC is equals to OD by OB. Right, so these two sides are in proportion. That means two triangles would be congruent by SAS rule, right? Triangles would be congruent, but writing the triangle in correct way is important. How you will write? Suppose you have written triangle AOD, right? That would be similar to either you will write COB or you will write BOC. Which one is correct you need to know firstly, okay? O is definitely equals to this O angle forming at O. That's why O is having same place in both, right? So here instead of AO is related with OC. So for instead of A you will write here as C. That's why angle triangle AOD is similar to triangle COD. So you have this result with you. Triangle AOD is similar to triangle COB. So comparing angles on both the sides, if you have two triangles similar, you will have its corresponding angles as equal. So angle A is equals to angle C and angle D is equals to angle B. That means A and C are correct answers. You have these as correct answers. Okay. Let's just go to the next question. Here is the next question for you. Two poles of height A and B meters are P meters apart. There are two poles which have height A meters and B meters. Two poles have height A and B meters and they are P meters apart. Find the height of the point of intersection of the lines joining the top of each pole to the foot of the opposite pole. Are you all getting what exactly is the question demanding? What is the question's demand? We have two poles of height A and B. This is the first thing which is given to you, and they are P meters apart. Second thing which is given to you, we need to find the height of the point of intersection when we join the top of one pole to the foot of opposite. Okay, yes, you got the question. So just solve it quickly. I'll solve it with you. Okay, so we have its figure something like this. Here, suppose this is A, B, this is C and D. A, B and this CD are two poles, suppose, and this A, B is A meters length, its height is A meters, and suppose DC has height this equals to B, and it is also given that they are P meters apart. If they are P meters apart, then this length would be equals to P, right? We need to find the height, this height where they are intersecting. We need to find this height. Suppose this height is equals to H. Suppose this is equals to H. So we need to find H. H would be equals to what? This is our requirement for the question. So let's just solve this. Suppose this point is, like, I just write this as this point is equals to Q and this point is R. I have just named this point so that it is easier for us to call these points. So let us discuss how we will solve. In triangle BCD, BCD is the first triangle I am considering. Okay, so here this height we always measure perpendicular to the surface, right? Height we always measure perpendicular to the surface. That means this is 90-degree angle. Again, this height, pole is always straight at a perpendicular to surface, right? So this angle is also 90-degree. If these two angles are 90-degree, that implies this side is parallel to this side, definitely, right? Because here alternate interior angles are equal. Like interior angles on the same side of the transversal are equal and their sum is 180 degree each. So if they are equal, that means these two sides are parallel. Or even you can say corresponding angles are equal. These corresponding angles are equal. That implies these sides, these lines are parallel to each other. If these lines are parallel to each other, so that implies you can apply BPT, basic proportionality theorem. If you apply basic proportionality theorem, you will have BQ by QC, or you can say that BQ by BC. You can have an advanced version of this BPT with you. If you apply this advanced version, you will have BQ by BC. Why I am writing BC? Because I know the length of BC complete. Okay, so BQ by BC is equals to your this length H by B, right? Because these two triangles would be similar. Why similar? Because these angles are 90-degree and even this angle is common to both the triangles. In triangle BQR and in triangle BCD. You have both these triangles similar. By which criterion? This angle is equals to this angle and this angle is common to both the triangles. So by AA criterion, you have this as similar. Or by using BPT, you can also write this result. From this result is from criterion, which is AA criterion. You can derive the same result either by BPT or by AA criterion. Okay, so you have this result with you which says that BQ by BC is equals to H by B. That implies BQ by BC can be rewritten as P, which is equals to H by B. You have this as your first result. Okay, next result can be seen if you see the triangle CQR. In triangle CQR and triangle CBA, by similar way, you will have this triangle. One is this triangle and other is this complete triangle. So these two triangles would again be similar. Why similar? Because now this time this angle is common to both the triangles. Even this angle is equals to this angle, which is 90 degrees. So by AA criterion, again you would say that these two triangles are similar. Okay, so if these two triangles are similar, you can say that CQ by CB is equals to RQ by AB, right? So just write the values of each. CQ can be written as it is. Again CB here, CB complete here is P. This is equals to RQ over here is H divided by AB length is A, right? So from this you can even write CQ is equals to H into P by A, right? This is first result, and from this you can write PQ is equals to H into P by B. You have these two results. Now what next I'll do is I'll add this first and this second equation. I will add both these equations. So you will have BQ plus CQ is equals to HP by A plus HP by B, right? So that will be equals to HP A plus B by AB, right? So this RHS I have solved as HP into A plus B by AB, and this BQ plus CQ, this BQ plus CQ, this can be rewritten from the figure as this BQ plus CQ is equals to P. This complete length is P, right? So we have P is equals to HP into A plus B by AP, that is P is equals to P into A plus B, H into P by A plus A into B. Cancel P from both the sides. You will have H is equals to AB by A plus B. You have height with you. Anyone having any doubt how we have written the height from this? Height required is A into B by A plus B. A into B by A plus B. Okay, let's just jump to the next topic. Next topic here is areas of similar triangles. How do we compare, like what relation do the areas of similar triangles have with them? Okay, so let's just jump to that section. How areas of similar triangles are related to each other. The result is as under. If two triangles here, if these two triangles are similar, I've said these two triangles are similar, then the area of these two triangles are related by this result. How? The ratio of areas of two triangles which are similar is equals to the squares of the ratio of the corresponding sides. That means take the ratio of the corresponding sides, whatever side you ratio of corresponding side you have, take it the same way. If you have ratio of AB by DE, just square it, and this would be equals to area of triangle ABC by area of triangle DEF. Or you can take AC by DF AC by DF, just square it, you will have the ratio for area. Or just take BC by EF and square the ratio. Okay, anyone having any doubt in this result? You need to remember this result. Do remember this. This would be used directly to solve the question. We will solve the questions related to this. The question related to this is this one. Diagonals of a trapezium ABCD with AB. Okay, Gagan, you are having no doubt. That's great. Try solving this question now. Diagonals of a trapezium ABCD with AB parallel to DC intersect each other at the point O. If AB is equals to twice of CD, find the ratio of areas of triangle AOB and COD. Okay, Srijani, you are even having no doubt. That's great. You are understanding the lecture. It was quite good session because you were interacting with me more. So I would say that do interact with me from each of the next session. Okay, definitely your sessions would be at 5:30 only, so do check from the next week. There might be some changes from next week. Okay, so do note it from the next week and let me know like whatever doubts you have in the sessions. Okay, so here we have trapezium ABCD where AB is parallel to CD. So we have a condition AB is equal to twice of CD. We need to find the ratio of the two triangles. Let's just draw the figure. Here we have a figure, right? We are given with a trapezium where ABCD is the name of the trapezium. AB is parallel to DC. Here it is somewhat wrong name. Here it would be C, it would be D, right? So ABCD where AB is parallel to DC, right? So next thing given over here is AB is equals to twice of CD. We would use it later on. Okay, so also it is given that they intersect each other. These lines intersect each other at O. Right, now find the ratio of the areas of triangle AOB and COD. We need to find the how area this is related to this. We need to find this. Anyone from the chat section who would like to answer what would be the ratio? Okay, I'll do it with you. Just see these angles. First angle is this one and next angle is this. Are they related to each other? Are these angles related to each other? This angle which I am marking as 1 and this angle which I am marking as 2. Angle 1 is equals to angle 2, or I can say that angle AOB is equals to angle DOC. Why equal? Because these are vertically opposite angles. Right, next this angle is equals to this angle. Why? Because AB is parallel to CD. That means alternate interior angles would be equal. So you have angle BAO is equals to angle ACD. Right, or you can say OCD, whatever you want to write. These two angles are equal. Now just see triangle AOB and angle COD. Can you see that whether these two triangles are similar to each other or not? Yeah, these were alternate interior angles. Okay, so triangle AOB and triangle COD, whether they are similar to each other or not. Anyone who can answer? They are similar or not? Yes, they are similar because by AA criterion, you can say that these are similar. Okay, because here this angle AOB is equals to angle DOC. So you have these two triangles as equal. So angle which is forming at O, this is similar. Even angles which is formed at A and C, this is also equal. So you can say that by AA criterion, triangle AOB is similar to triangle COD. right? So these two are similar. If these two are similar, then the ratio of their area of triangle AOB divided by area of triangle COD, that would be equals to ratio of their corresponding sides square of their ratio of corresponding sides. You have a relation between corresponding sides. AB by CD from this equation can be written as 2 by 1, right? So you have ratio of AB is to CD, AB over CD square. Using the result which we have done in previous slide, this is AB by CD square. So that would be equals to 2 square, that is 4 is to 1, 4 by 2 square by 1 or 4 is to 1. So these have ratio equals to 4 is to 1. Required ratio is 4 is to 1. If the triangles are similar, then their corresponding sides will be in equal ratio. Yeah, their corresponding sides would be in equal ratio, but we are given with one of the ratios, so we have used only that. You can, if the requirement is to find the other ratios, then we would have used the ratio of corresponding sides of like other corresponding sides. But here the requirement is only of one, so that's why we found our result from only one of the ratios. Okay. So with this, I just end this session. Thank you all for like interacting with me more and more in this session. If you want like more questions to be done, like instead of just this one short sessions, you need full-fledged topics to be covered with us. Do download our Practically app and get enrolled with us for our paid sessions over here. You will definitely find it more interactive and in more enhanced way, because you will be getting 3D models by which you can learn the topics completely. Okay, so do download our Practically app and get through, like see the simulation videos which are provided over here for free. Definitely you will have an enhanced learning with you. Okay, so and also share this link with all your friends or your society friends or your school friends, those who are from 6th to 12th grade. Okay, so we'll meet you in the next session. Till then, goodbye, take care.